So dear students, in this video we are going to discuss about conversion of Gala meter. So conversion of Gala meter, how the Gala meter can be converted into ammeter and voltmeter. What is Gala meter? It is a device is used to indicate the flow of current in any circuit. But Gala meter does not measure the current, but we can indicate whether the current flow through the any circuit or in this conductor. We can measure the current flow through R by using the deflection. If the deflection not occur in Gala meter, no current flow through the any circuit. But the Gala meter is only used to indicate only the flow of current, but it does not calibrate what is the value of ampere, what is the value of the volt. But volt and ampere can be measured by using some conversion with help of the Gala meter. Let's see, first one is how the Gala meter can be converted into ammeter. Ammeter is an instrument to measure how much the current flow through the any electrical circuit. How to convert Gala meter into ammeter? Ammeter is not a single device. So ammeter is calibrated from some other things. From this Gala meter, we know that the Gala meter is a very sensitive device. By using the moving coil Gala meter, we can measure the current up to 10 power minus 8 ampere. 10 power minus 8 ampere. Imagine 10 power minus 8. So this is very sensitive. If small current flow through the circuit, there will be the large deflection in a Gala meter. So we can measure up to 10 power minus 8 ampere by using moving coil, that is moving coil Gala meter. Okay, let's start. How the Gala meter can be converted to ammeter to measure the how much the magnitude of the current flow through any circuit. Ammeter. Let's consider this is the Gala meter. If the large amount of current flow through the Gala meter became damaged. To avoid the damage in the Gala meter, so only the small amount of current must be flow through the Gala meter. For that we have to change some conversion. So it is a highly sensitive. So the I is the amount of current, any amount of current passes through the Gala meter became damaged. To avoid the damage, we have to convert something. So bypass the current by adding some other resistance across the Gala meter. This is the resistance. So I amount of the current flow through the circuit. This is the junction. Already we have studied the Kirchhoff first law. According to the Kirchhoff first law, current flow through the circuit is equal to current away from the circuit. The total current through the junction is always equal to 0. So how much current flow through the circuit? The same amount of current can be divided. So 100% of the current flow from this circuit at this point, suppose the point A, this is the B, this is the C, this is the D, this is the E. At this junction, if I enter the junction, some amount of current can passes through the Gala meter, remaining amount of the current passes through in this region. What is this? This is the resistance, something is connected across the Gala meter. Now the Gala meter can be converted to ammeter by connecting low resistance. So Gala meter can be converted to ammeter by connecting low resistance with parallel. So this is a low resistance. So low resistance is always called shunt resistance. This is called shunt. S represents shunt. Shunt means parallel. So the I amount of the current flow through the circuit. At this junction, some amount of current flow through this is divided. So the current flow through the Gala meter is Ig. Current flow through this circuit is, suppose I divided into Ig into some other value. So how much current here? 10 ampere current flow through the circuit. Suppose only the 1 ampere current passes through the Gala meter. Remaining 9 ampere current flow through the junction. That means I minus Ig. 10 minus 1 ampere. So the 9 ampere current flow through the circuit. So this circuit connected across the Gala meter whose resistance is very low. If the resistance of the resistance, shunt resistance is very high, if the shunt resistance is very high, the resistance does not allow more amount of current, the majority of the current flow through the Gala meter becomes damaged. To avoid the damage, so we have to connect parallel to the Gala meter, that is a very low resistance. So how to convert the Gala meter into ammeter? Simply you can say Gala meter can be converted to ammeter by connecting low resistance in parallel. Low resistance in parallel. Suppose if you connect the resistance of value is very high, other than the Gala meter, so very feeble current flow through the shunt, large amount of current flow through the Gala meter become damaged. We are unable to find out the current through the Gala meter. Okay. Now, this entire part, this is called ammeter. That's an ammeter. So this is a Gala meter. The Gala meter does not calibrate the current directly, but calibrate the current by connecting low resistance across the Gala meter. Now it becomes Gala meter. Gala meter measures some amount of the current. So Gala meter can be converted to ammeter by connecting low resistance with a parallel. That means shunt resistance. Shunt means parallel. Okay. The I amount of the current flow through the Gala meter at the junctions divided into two parts. Ig current flow through the Gala meter, remaining current I minus Ig through this shunt. So this is called Ig. Otherwise it's called Ig. Sorry, IS, not Ig. IS. Ig represents current flow through the Gala meter. IS represents current flow through the shunt. Now the Ig plus IS here becomes I. So Ig plus IS. In this point, the current flow through the resistance. So the same 10 ampere can be taken across at the point F. Same 10 ampere. So IS plus Ig at this junction. So Ig and IS. Okay. Let's start how to calculate the shunt resistance by using some calibration. Gala meter can be converted to ammeter by connecting low resistance. Is a low resistance. So these two connections. So the Gala meter, let's consider Gala meter resistance. G represents Gala meter resistance. S represents shunt resistance. Ig, the maximum current flow through the Gala meter to get maximum deflection. That is, the Gala meter requires maximum current to get full scale deflection. Full scale deflection, how much current flow through the Gala meter? Ig. So maximum current required to get full scale deflection. Ig. So G represents the Gala meter. Gala meter has some own resistance, that is called G. Current flow through the Gala meter is Ig. So the Gala meter requires some amount of the current to get so full scale, not half scale, full scale. That is Ig. That's the maximum current required. Current flow through the circuit, yes. That is shunt resistance Is. So value of shunt is S. By using this, now we are going to calculate the S. The value of S, this value of shunt resistance depends on fraction of the current flow through the Gala meter. The value is lesser or lower, whatever may be, 1 ohm, 2 ohm, 3 ohm or 0.1 ohm, 0.2 ohm, highly depends on fraction of the total current flow through the Gala meter. So this value decides only fraction of the current flow through the Gala meter. Since the connection is a parallel, it's a Gala meter, this is a shunt. Already you have studied in current electricity. If any circuit in a parallel connection, effective resistance, we can calculate. How to calculate the effective resistance? And also, the current flow through the circuit is not same. The current flow through any circuit, it is in a connection parallel divided. But potential across a Gala meter, which is equal to potential across a shunt. What is a potential across a G, which is equal to potential across S? Potential across Gala meter is equal to potential difference. So since connection is a parallel, potential difference. What is the potential across this Gala meter is equal to potential across? Yes. What is the formula to calculate the potential difference? By using the Ohm's law, V is equal to IR. You know that. V is equal to IR. Potential difference across the Gala meter. So the potential across the Gala meter is equal to potential across the shunt. V is equal to IR. So VG represents potential across the Gala meter is equal to V is equal to IR. I represents the current flow through the Gala meter, IG. R represents the resistance. What is the resistance of the Gala meter is G. Okay. Now IG is equal to VG is equal to IG into R. What is the potential difference across a shunt? The same formula, V is equal to IR. So V across S is equal to IS. Potential across the shunt is IS. Current flow through the shunt is IS. Resistance R is equal to S. I suffix S. That means the current flow through the shunt. S represents the shunt resistance. So VG is equal to VS. VG is equal to VS. What is the VG? IG into G. What is the VS? IS into S. What is IS? This IS equal to I minus IG. IS is equal to I minus IG. Okay. So IG into G is equal to I minus IG into S. From this, we can calculate the value of the shunt. Shunt resistance could be calculated. The shunt resistance is highly depending upon fraction of the total current, not more current. Fraction of the total current. That means lesser than one part. Fraction of the value of the shunt can be determined the fraction of the total current flow through the Gala meter. So S is equal to S is equal to IG, I minus IG into G. IG represents the current flow through the Gala meter. I represents the total current flow through the circuit. So G represents Gala meter resistance, S represents shunt resistance. So the shunt resistance could be calculated by using the formula S is equal to IG divided by I minus IG into G. So this is the main formula. If we know this formula, we can convert anything. If you want to calculate G by changing this value, we can calculate the any value. So S is equal to IG divided by I minus IG. If you want to G is equal to take some other value. Yeah, the other side we can calculate any value. Okay. One more example. If current flow through the circuit is only 1%, that means Gala meter. 100% is the current coming from the source. 100% is the current coming from the source. Only the 1% is the current flow through the Gala meter. What is the value of the shunt? How to calculate? If 1% of current flows through a Gala meter, what is value of shunt. So the shunt decide only the fraction of the total current flow through the Gala meter. So 100%, that means it may be there 10 ampere current coming from the source. 10 ampere current. Only 1%, that means 1 ampere current flow through the Gala meter. Remaining current can bypass through the shunt. That means 9 ampere. Now that is why we are considering is at 100%. It may be the 1 ampere, 2 ampere, 3 ampere, whatever may be. 100% ampere current flow through the circuit. Only 1% passes through the Gala meter. So 1% is the current enough to deflect a full scale of Gala meter. Remaining current flow through the shunt. What is the value of the shunt? We can find out value of the shunt. Yes. So formula S is equal to Ig divided by I minus Ig into G. G represents the Gala meter resistance. It may be the Gala meter resistance 100 ohm, 10 ohm, 99 ohm, whatever may be. So G represents the Gala meter resistance. So S is equal to, what is Ig? Ig is 1%. 1%. 1 by 100. Divided by, what is I? I 100%. I is 100%. 100 by 100, 1. That's the one part. 1 minus again Ig 1 by 100 G. Okay. 1 by 100 S is equal to 1 by 100. 100 minus 1 divided by 100 G. So 100 minus 1 by 100. Okay. 100 minus 1, 99. So S is equal to 1 by 100 by 99 by 100 into G. 100 cancel. So S value G divided by 99. So S value calculated. If only 1% current flow through the Gala meter, the S value decide G by 99. G by 99. Suppose G is equal to 100 ohm. Resistance of Gala meter is 100 ohm. So S is equal to 100 by 99, approximately is equal to 1.01 ohm. 1.01 ohm is very, very smaller compared with the Gala meter. 100% coming from the source, only the fraction current flow through the Gala meter, value of the S. If value of S increases, current also increases. That means if value of S decreases, the current flow through the G is decreases because it allows more current flow through the shunt. That is why shunt is very low resistance. Like consider the Gala meter resistance 100 ohm. Gala meter resistance 100 ohm. Shunt resistance 1.0, almost equal to 1. 1.01. This is compare. Whose resistance is greater? Gala meter resistance is greater. Shunt resistance is very low. If the shunt resistance is very high, we are unable to calculate the current flow through the any circuit. But what is the value of, what is the resistance of the ammeter? Resistance of the Gala meter is a G. Resistance of the shunt is S. The current flow through the circuit, that is get full scale difference for the Gala meter is Ig. The current flow through the circuit is Is. What is the resistance of the ammeter? What is the resistance of the ammeter? Already we have studied. If any circuit connected in parallel, it is a 2 ohm, it is 3 ohm. What is the effective resistance of the circuit? This effective resistance calculated. This is RP. RP represents parallel connection. 2 ohm and 3 ohm, two resistors connected in parallel. What is the effective resistance of the circuit? Effective resistance should be calculated. 1 by RP is equal to 1 by 2 plus 1 by 3. So 3 plus 2 by 6, 5 by 6, 1 by RP. So RP is equal to 6 by 5. It's also equal to 1.01. Consider the first resistance is 2 ohm, second resistance has a resistance 3 ohm, but the effective resistance is RP or effective. R effect is 1.01. That means if any resistance are connected parallel, effective resistance always lesser than the least. Okay, which one is the least? 2 ohm is the least. But effective resistance 1 point something. So any connection connected in parallel, effective resistance always lesser than the least. Same way, Gala meter has resistance 100 ohm. Shunt resistance has 1 ohm. For example, what is the resistance of the ammeter? Resistance of the ammeter always lesser than the least. Okay, which one is lesser? Shunt resistance. Shunt resistance 1.01. So effective resistance of the Gala meter always lesser than yes. Already S has 1.1. So the effective resistance always lesser than the S. So more amount of current flow through the ammeter. That is why any circuit, any electrical network, ammeter must be connected in series, not in parallel. So any circuit, this is the electrical circuit. To measure the how much current flow through the circuit must be connected in only in series. But resistance of the ammeter is very low. Resistance of the ammeter very low. So 1 by RA represents effect resistance of ammeter. 1 by RA is equal to 1 by G plus 1 by S. Because since connection is a parallel. So connection is parallel, effect resistance 1 by G plus 1 by S. So 1 by RA is equal to S plus G divided by GS. So RA is equal to GS divided by G plus S. G 100, S 1 point something, 100 plus 1. 100 plus 1. So this denominator 101. Denominator 101. G into S. So numerator is 100. So definitely it is less than 1. The value is less than 1. So the resistance of the ammeter always lesser than the least. Lesser than the least. So ammeter resistance always very low compared with which connected across parallel connection shunt. So value of ammeter always very low. Suppose in the case of ideal ammeter, ideal ammeter, generally resistance of the ammeter is very low. Resistance of the ammeter very low. Ideal ammeter is equal to 0. Or ideal ammeter resistance 0. Suppose generally if anyone is asking the question, what is the value of ammeter? What is the resistance of the ammeter? Resistance of the ammeter is very low. If the ammeter is ideal, value of resistance is 0. Why? Because already has very low value. If whatever may be the current, suppose 10 ampere current flow the circuit, same 10 ampere measured by ammeter. Not 9.9, 9.8 and some other value. So the same amount of the current, because appreciable, there is no appreciable change. How much magnitude of the current flow the circuit, the same amount of the circuit can be measured by ammeter. That is why in any circuit, in an electrical network, ammeter is one of the instruments to measure the magnitude of the current through the circuit, measured only in a series connection, not in parallel connection. So by using this formula, the shunt resistance can be calculated. So S is equal to Ig divided by I minus Ig. S is equal to I minus Ig divided by I minus Ig. If any kind of value, we can measure. For example, MCG represents moving coil Gala meter. Moving coil Gala meter resistance (20 ohm), which produce full scale deflection (50 milliampere). The moving coil Gala meter of resistance 20 ohm, which produce a full scale deflection of current of 50 milliampere. How will you convert the Gala meter into ammeter? Range of 20 ampere. Range of 20 ampere. How will you convert? Gala meter into ammeter. Ammeter range of 20 amps. Okay. You are given a Gala meter. That's a Gala meter is resistance is 20 ohm, but which require 50 milliampere to get full scale deflection. Full scale deflection. Now this, how to convert this ammeter range of 20 ampere. Ammeter range of 20 ampere. Okay. Select the formula. Yes. Let's consider the other one more problem. Moving coil Gala meter of resistance of 20 ohm, which produce a full scale deflection of 20 milliampere. How will you convert this into ammeter range of 20 ampere? Ammeter range of 20 ampere. So select the formula. Yes. Yes is equal to Ig divided by I minus Ig into G. So G represents the Gala meter resistance. This is the G. This is Ig. So range, how much? 10 ampere, 20 ampere range. Now substitute and get it S value. So S is equal to Ig 50 milliampere. So 50 into 10 power minus 3 divided by I 20 minus 50 into 10 power minus 3 into G is equal to 20. G value is equal to 20. Okay. See the 20 minus 50 into 10 power minus 3. See is very low value. Compare with the 20. 50 by 1000 or 5 by 100. It's very low. 0.005 this is a value. So this is neglected. So let's consider only the 20. So S is equal to 50 into 10 power minus 3 into 20 divided by 20. 20 cancel. So S is equal to 50 into 10 power minus 3 or 5 into 10 power minus 2 ohm. So 0.05 ohm. The value of S connected across the Gala meter. If the current flow through the Gala meter gets a full scale deflection of 50 milliampere, the Gala meter resistance is 20 ohm. The range of ammeter, this entire range of ammeter to measure the 20 amps, how much resistance must be connected in parallel? It is 0.05 ohm. 0.05 ohm. So, a Gala meter can be converted to ammeter by connecting low resistance in parallel. Even though the deflection of the Gala meter is directly proportional to current. Also directly proportional to current. See the Gala meter. Generally, moving coil Gala meter is used to measure the how much current flow through the circuit, but we can indicate the formula by using this. I is equal to G theta. I is equal to G theta. What is I? Current flow, the entire total current flow through the Gala meter. G represents a Gala meter constant. So I is equal to G NBA by C theta. So G is equal to NBA by C. N represents the number of turns. The rectangular coil which is suspended between the pole of bar magnet, that's R2 magnet. B, magnetic field. Magnetic field of R2 magnet. A represents area of the coil. C represents couple for unit twist. So this part is called Gala meter constant. So I proportional to theta. I proportional to theta. Even though deflection directly proportional to current, but the Gala meter does not calibrate the value of the current flow through the circuit. I proportional to theta, but we are unable to calculate how much magnetic current flow through the circuit. But we need some conversion. Directly we cannot measure by using the Gala meter. So the conversion means Gala meter can be converted to ammeter by connecting low resistance in parallel. If you connect the low resistance in a parallel, so the entire part becomes ammeter range. So the ammeter range. So the value of S decide only the fraction of the total current flow through the Gala meter. Okay. Suppose the entire ammeter range is measured n times. N times. What is the value of S? If range of voltmeter, range of ammeter. It is n times. Range of ammeter is n times. How to calculate the value of the S? So S is equal to Ig divided by I minus Ig. So the current n times 1 ampere, 2 ampere, 3 ampere, that's n times increases. So S is equal to Ig divided by I becomes Nig minus Ig. So S is equal to Ig divided by, you take Ig is a common outside, n minus 1, Ig cancel. So S is equal to 1 by n minus 1 into G. So G divided by n minus 1. If range of ammeter increases n time, range of ammeter increases n times, the value of the shunt could be calculated by using the formula S is equal to G divided by n minus 1. So far we discuss how the Gala meter can be converted to ammeter, but next class we will discuss how the Gala meter can be converted into voltmeter.